afternoon, George. I'm游佩綈from the Department of Material Science and Engineering. Today, I'd like to share with you a fascinating cancer therapy called Boron Nutron Capture Therapy, or BNCT. Let me start with a quick question. What if we could destroy cancer cells without harming the healthy ones? That's what basically BNCT tries to do. In brief, when thermal neutrons hit the boron cap, it triggers a nuclear reaction that produces high-energy particles. These particles travel only a very short distance, about the size of a cancer cell. So if boron is only inside the cancer cell, not in the normal cell, only this cancer cell will be destroyed. And that's how BNCT works. In clinical, patients first receive a careful diagnosis and personalized planning. After that, the patient was injected by the medicine called BPA, and then doctor monitored whether the boron content achieves the efficient level in tumor. If it is reaches the efficient level, the patient was lying in front of the neutron irradiation system to post the irradiation. The whole sessions are very fast, so it reduces the burden for the patient. Density sounds advanced, but in fact, it can track back to 1930s. The scientists discovered this nuclear reaction may be useful to the cancer therapy, but at that time, the technology wasn't developed yet. So it wasn't until the next 20th century the BNCT started began forward. And in 2023, Japan officially approved BNCT as a clinical cancer treatment. But it still has a lot of room to improve, and that's why material science have to engage in. The first part is to improve neutral source and shielding materials, because we don't want to set up a nuclear reactor in the hospital. So we have to think how to modify it to provide the sufficient neutron beam. And the second part is to improve the efficiency of boron carriers, which can lead stronger treatments and less side effects. The third part is to use nanotechnology, because we have to let boron only stay in the cancer cell. So we have to use a nano vehicle like a GPS to guide the boron toward the tumor cells. And the final part is to use bioimaging materials, which can help doctors to monitor the boron content more instantly, which can help the real therapy. So to sum up, BNCT is a modern therapy, but we still have a lot of effort to do. Let's the BNCT more accessible to the public. Thank you for listening.
Thank you for the presentation. I'm just really curious how the boron neutron target the cancer cell instead of the normal cell.
Yeah. Okay, so because we know some cancer cells in its morphology, there are several enzymes and receptors that normal cells don't have. So we design some functional on the boron drugs, and this functional will trigger it only to target a cancer cell, but not a normal cell, because normal cell they didn't have the receptor.
Is there any limitation for this kind of therapy? For example, is limited to the brain tumor, or it can also use in treatment on other types of tumor?
Now, a lot of type cancer, if it's are still in the experiment stage, but But I know in Japan, the neck and head cancer can use this Boron Nutron capture therapy. And in Taiwan, some patients have brain cancer will be a special case to monitor by doctors, and they depend whether the patients can use this therapy.
So is there any consideration for patient to get into this type of therapy? What kinds of consideration you?
Now, for example, if you want to treat brain cancer, you have to make sure our patients they have NLAP1 protein, which can let BTA target to the tumor. If patients lack this protein, he cannot use this therapy.
Thank you.
Just a small advice, you should use Grammarly next time because you missed the E here, the title. NEU. You should check your neutrons. It's easy, just use Grammarly and you can spot the type of.
Okay, thank you.
Yeah, sure.